Hello, so today in this video we're going to be going over 1015 chapter 2.7.2, which is solving systems of equations in three variables. We're going to be using a lot of techniques that we learned from chapter 2.6.2 and 2.6.3, which is substitution and addition, which is also known as, oh man, I'm trying to remember, elimination. Yeah. So if you are confused by some of the things that we're doing, please go give those two videos a watch and maybe some of your questions will be cleared up. But for now, for those of you who are on board and aware of how that works, we'll just hop into these. So with these, it's going to be with systems of three equations. It's going to be very similar, but there are a few things that change in the beginning. We have three systems of equations, and we need to get rid of at least one of our variables to use our other two methods that we've learned, substitution and elimination. So what we can do is we're going to make two different equations. I'm going to label this 1 and this one 2 and this one 3, or maybe actually I'll change it to A, B, and C. So what I like to do is I like to say, okay, let's choose a variable to get rid of. And it looks like I want to get rid of X because there's two 7s, and that will make it easier for me to get rid of things. Well, actually, now that I think about it, I think Z might be easier because then I won't be dealing with any fractions. So I'll take A and B, so 7x minus 3y plus 2z equals 33. And I'll take 2x minus y plus z is equal to 11. And I'll say, what can I do to these equations to make it so I can get rid of z? And it looks like I can times this bottom equation by negative 2. So I have negative. So first I have 7x minus 3y plus 2z equals 33. And now I'll times the bottom by negative 2, which gives me negative 4x plus 2y minus 2z equals negative 22. Now what I can do is 7x plus, now I add these two together, so it's very similar to elimination. So 7 minus 4 is 3, so 3x. 3 minus negative 3 plus 2 is going to give me negative 1y, so negative y. These will eliminate, so plus 0 is equal to 11. Now we have one equation, and it's going to be AB. We need two equations to deal with it like one of our systems of equations. And we can't do the same thing to the same two. But what I'm going to do is I'm going to take A and C. You could also take B and C. It doesn't matter. And I'm going to do basically the same thing. So 7x minus 3y plus 2z equals 33. And 7x minus 4y plus 4z equals 41. And what I'm going to do is I'm going to times this equation by negative 2, so I can get it, so I can delete the z's. So I have negative 14x plus 6y minus 4z is equal to negative 66. And 7x minus 4y plus 4z equals 41. And now I'll add these two together. I'll get negative 7x plus 2y plus 0 is equal to 66, 66 minus 41. We'll keep the sign of the largest, so which is going to be 5, 2. We'll get 25, negative 25. Now we'll take these two, and this is going to be AC. And now we can compare these two. So negative 7x plus 2y plus 0 equals negative 25. And we can treat these two equations as if they are two separate, as if it's a completely separate problem. We want to take these two and we want to make it so it's going to be solved like another system of equations, like a completely separate system of equations. So we'll take this and we can do either elimination or substitution, whichever one you prefer. I'm going to do elimination. So I'm going to take this first one and times it by 2 to get rid of the y's because that looks easier to me. So I'll have 6x minus 2y equals 22. And I'll have negative 7x plus 2y plus 0 or equals negative 25. And I'll add these two together. that'll give me negative x plus 0 equals negative 3. Divide both sides by negative 3, and that gives you x equals positive 3. What you can do now is you can go to the top equation again, and you can plug in x equals 3 and see what you get for that. So we'll do 3 times 3 minus y equals 11, which gives you 9 minus y equals 11. Minus 9 from both sides, we'll get negative y is equal to 3. 2. And then that will give you y is equal to negative 2. Now we can go back to our original equations. And we know 3 and negative 2, so 3 comma negative 2, and then we'll leave a space for z. And we can plug in our values to this equation. I'm going to do b because it deals with the lowest numbers. That's what I like to do. I like to make things easier for myself. So 2 times 3 minus negative 2 plus z equals 11. And that gives me 6 plus 2 plus z equals 11, which gives me z is equal to 11 minus 8, which is going to give me 3. Z equals 3. Now what we can do is we can plug all of these back in to see if it works with another one of our equations. So I have 7 times 3 minus 3 times negative 2 plus 2 times 3 equals 33. And we can see if that works. See, it's a lot of work. So 21 minus, it's going to be plus 6, because negative times a negative is a positive, plus 2 times 3, which is 6, equals 33. This is going to be 21 plus 12. That's going to give us 33. So this is our solution. You could try with the other two, but you don't really need to do that. It's a lot of work. I would recommend doing it on tests. And then you'll write it as a ordered pair, ordered triplet. And so our solution would be 3 comma negative 2 comma 3. That was a lot of work, and there's a lot of places where you can go wrong with your calculations. So I really recommend using a calculator for some of your calculations, because it's really easy to go wrong in a lot of places. So yeah, we'll move on to the next problem. And this one's a lot easier. We want to find the solution to the given systems of equation, and it actually already gives us some of our answers. So we know that x is equal to 6 and y is equal to negative 5. Now all we need is z. So we can take our third equation, which has z in it. We'll do 6 minus negative 5 plus z equals 14. That gives us 6 plus 5, which is 11, plus z equals 14, minus 11 from both sides. Z will equal 3. And that would be our answer. It's kind of hard to check that with, because there's only one equation that has those, that has all three variables. But you can guess that this is our solution. You can say that. Next, we'll go down to this one, solve the given system of equations. I'm going to do this one, again, more in depth. So what I can see is, I think it would be easiest to get rid of our y's, because all of them are either 4y or negative 4y. So I'll take a, b, and c. I'll take a and b first. So 6x minus 4y plus 3z is equal to negative 13. And I'll take b, which is 12x plus 4y minus 6z equals negative 2. I'll add these two together, and that'll get rid of our y. So we'll have 18x plus 0 minus 3z is equal to negative 15. And that's one of our equations. That's AB. And now I'm going to take A and C. So 6x minus 4y plus 3z equals negative 13. And I'm going to take C, because that one I won't have to modify the equation in any way. So negative 24 plus 4y minus 2z equals 30. And I'll add these two together. This will give me, 24x. 18, negative 18x plus 0 plus z equals 43. And now we have AC and AB. We can take these two and compare them. So we have 18x minus 3z equals negative 15. And we have 18x, negative 18x plus z equals 43. And this one is really nice because we actually don't need to modify our x's at all. We can just get rid of our x's to find our z's. So 0 plus 2z, well, it'd be minus 2z, equals 43 minus 15. One moment. 5, 8, 28. And then we can divide both sides by negative 2. Which gives me z is equal to negative 14. Sometimes when I get numbers like this, I get a little concerned because I usually expect it to be like negative 1, negative 2, negative 3, positive 1, 2, 3. Just because those are easier numbers to deal with. But we'll just keep this in mind. Z equals negative 14. And we'll come back to one of our top ones. We have negative 18x. We'll do the positive because that's easier to deal with. 18x minus 3 times negative, what was it? Negative 14 equals negative 15. So we'll do 18x and then negative 3 times negative 14 is going to be, 42. Positive 42. Equals negative 15. And then we'll add minus 42 from both sides. So we have 18x equals 42, 15, 7, 57, 57. Divide 18 by both sides. Okay, I made a mistake kind of early on. Because things were not adding up all the way to me, and that's a good pointer. So what happened is I forgot the negative 13 here. So negative 13, so it'd be 30 minus 13 instead. Sorry about that. It's really, really easy to make little calculation errors or like just little mistakes, and it's really good practice to write down each one of your steps so you can go back and look at where you got things wrong. So instead it would be equals 17, my bad. Which still is kind of gross because, well, it's fine. We'll deal with it. So we'll write these back together. The x's will cross out still. So we'll have negative 2z is equal to negative 15, positive 2. Z is equal to negative 1 instead. I was thinking something felt a little bit fishy with that. It's really weird when you get weird big answers like that. So now what we can do is we can say, okay, negative 18x plus negative 1 equals 17. We'll add 1 to each side, so we have negative 18x equals 18. So we'll have x is equal to negative 1 as well. Now we can go back up to one of our equations. We have 6 times negative 1 minus 4y plus 3 times negative 1 equals negative 13. That gives us negative 6. And then minus 3, which is negative 9, minus 4y equals negative 13. We'll add 9 to both sides. So we'll have negative 4y is equal to negative 4, which gives us y is equal to 1. And now what we can do is we can plug in these solutions to another equation. So negative 24 times negative 1 plus 4 times 1 minus 2 times negative 1 equals 30. Let's try that. And you'll get 24 plus 4 plus 2, which is going to give you 30. 30 equals 30. So this is our solution. Negative 1, comma 1, negative 1. Whew, that was kind of a hard one. Now this one is going to be very similar. Lucky for us, though, we already have basically an equation that we can mess with. We have y minus 3z equals negative 6. So what we want to do is we only need to modify to have one of our equations, and we need to get rid of x. So we'll take our first one, x plus y plus z is equal to negative 3. which gives us 2x plus y plus 5z equals 1. What we need is we need to multiply this whole equation by negative 2. So we get negative 2x minus 2y minus 2z equals 6. And we'll get 2x plus y plus 5z equals 1. These will cross out. We'll get negative y plus 3z is equal to 7. So now we have negative y plus 3z is equal to 7. Now these will cross out, and these will also cross out, which causes problems. I think that this is going to be a no solution one, because we'll get 0 is equal to 1, which is not true. Yeah, and so when I try no solution on that equation, it is no solution. That's correct. And the reason why is because 0 does not equal 1. So if you come into a dead end like that, it doesn't matter what you find for other variables. If you get something that is like not possible, that's going to be no solution. Yeah, and then again, as always, if you get 0 equals 0, it's going to be infinite number of solutions. It's a little bit trickier with 3 systems of equations, though. If you have any other questions, please let me know, and I will answer them as soon as possible. Yeah, okay, have a good one.